If you understand scenarios 2 and 3, then scenario 4 is easy because it's just a combination of 2 and 3. Recall that in scenario 2, the real accident year loss ratio increased from 60% to 65% to 70%. Now, the raw data in the paid and reported triangles increased correspondingly, but the development patterns remained stable, so our estimates of ultimates remained accurate. In scenario 3, we increased the case outstanding strength by 20%, and that caused our reported development estimates to be too high. In scenario 4, where we are now, we make both changes at the same time. So, what do you think is going to happen? Just pause the video if you want a little time to think about it first. So, the paid loss method is exactly the same as in scenario 2. You can see the bump in losses in the data triangle corresponding to the bumps in the simulated loss ratio. The change in case reserve strength does not affect the paid triangle. Now, the development pattern for the paid triangle is completely stable, and you can then see from the summary table that our estimates of ultimate based on the paid development method are exactly accurate. Now, let's look at the reported loss triangle. It's a little bit more complicated. The bump in loss ratio affects whole accident years, which is a horizontal line. But the bump in case reserve strength affects whole calendar years, which is a diagonal line. So you can see how this can get complicated pretty quickly. But the key question, as always, is how is the development pattern affected? If you take a look at the loss development triangle, you'll see, actually, if you compare this to scenario 3, you'll see that these LDFs are exactly the same. That's because the bump in loss ratio does not affect the development pattern. These distortions are due entirely to the increase in the case reserve strength. So if you select an all-period average, which isn't the smartest thing to do, by the way, you'll get the same result as in scenario 3. So if you look at the summary table, you'll see that for accident years 1, 2, and 3, we do get the correct answer. That's because the case reserve strength increase didn't happen until t equals 4, which means that accident year 4, 5, and 6 are going to be affected, and those estimates are going to be too high compared to the real accident year ultimate loss ratio. Again, we will see how to correct for this distortion in a later chapter when we look at the Berkowitz-Sherman method.